Make sure they also have a picture of you. Saying you're too late, you'll be in your homecoming parade float. But you can give it a shot at PreCalc.com/homecoming. Like show work. And for all games and events, students, you can dress up to the theme of the day. No props, no signs, no toys, and nothing extra. You'll be asked to leave if you bring any of that. Dressing up for the theme of the day, make sure you sign up. We'll lock camo and orange today. Good job with that. At the end of the day, we draw for winners. Yesterday's winners for the dress-up day. Sam Snyder, Jackson Graham, and Mariah Eisenbrock. You all three need to stop into the office, get a $25 gift card to Goodfellas. Tomorrow is just a base class color day, right to your brown. Green, seniors are blue, seniors are pink. That, hi guys. Young Life All-Nighter, have not picked up the information by now. I'm saying you're probably running out of time as well. That form and information is interested in the Air Force. The recruiter resets the comments during lunch next Tuesday, September 28th. Stop by and visit. Interested in the United States Air Force. So all please stand for the pledge. To the flag
of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All have a great day.
How we doing? Is anyone still going? Okay. Anyone? We're there? There or stuck? Okay, your antlers are seriously like weirding me out. Every time I look over, I think someone's raising their hand. All right. You can't do transformations if it's not in transformation form, right? If I don't see g of x is Frank. Frank. Let's just rewind 20 years because we're going to be cheap. If I don't see a times, this is square root, so b x minus h plus k like this, then it's not in transformation form yet. If I want to find what the transformations are, I need to turn it into that. Now don't go simplifying, because there is a way to simplify this. There is a way to turn the b into the a. We don't do that yet. I just need to, g of x is 5 square root of, how about I take that negative 4 out? X minus 2. Factor out. Plus 9. Minus 9. Now I have Now I've got transformation form. Now I know what B is. Now I know what H is. So we have a vertical stretch by a factor of 5. We've got a horizontal reflection, or reflection in the x-axis, or y-axis. God, I hate being over here, just messing with me. Be careful with 4. 4 in the B spot. What does that do? Horizontal compression by 1/4. And then a horizontal translation, right 2, and a vertical translation, down 9. Now,
It's supposed to be +2.
no? Bass backwards land. Now, is there anyone who then said square root of 4 is 2, like this? No? Because now you can't just take that 4 out as is, because that's a sum. I need factors to take something out of radical land. I could have had g of x. Nope. I could have had g of x is 10 root of negative x minus 2 minus 9, like that. Did anyone do that? Well, you didn't have to go get it. It's a treasure for someone. No one did that? Okay. If you did, technically this is what you're supposed to have. You're not supposed to simplify and then tell me transformations, because now they're completely different transformations. But if someone did go here and then say vertical stretch by 10, only the reflection, now no horizontal compression, I would have taken that. So, I'm concerned the blank stares say we don't remember how to do this. Who in here even did that? Like 5 of you. All right. So we don't remember that from Algebra 2. Okay. Then, seriously, why aren't you working? It won't matter. It's just, oh, you POS. Really? All right. It might work. Okay, now you're over there. Now we do it again. There we go. Okay, so theoretically, I'm headed down to our tech guys next hour to have them just put all my stuff back on the old computer. Then, let's try that again with try again. Just completely cross out the other one, okay? If we hadn't explicitly gone through radicals, I know we review them again in chapter 2. Maybe we just needed to do a little more work with B values. Okay, let's just try that. Nice and simple. There's 4 transformations. Do the thing, graph it. Okay.
So when you say write the parent function, does that mean label what parent function it is?
What is the parent function of that?
Okay.
I see Maddie. Who's the daddy? Not restaurant sugar daddy, like actual father. Clean up my change jar too. Okay, so just try that again. Oh. Yeah. Frank was writing on my other screen. Well, they're hoping that if the new docking stations come in, it'll alleviate some of these problems, because we're using the old replicator ports from the old computers, because there was a massive distribution and production problem with the docking stations. They were back ordered like a year and a half. Yeah. This one going a little smoother? Okay. Gotta say, please make sure you get some graph paper. You're going to be doing a lot of it in this class. Not everyone's handwriting's neat enough to make the graph accurate or legible. Anyone still going this time? Finishing up? What's up?
So if I make my scale like twos, am I still do like a 1, 1, like the boxes?
If you make a scale, you just have to match your graph to that scale. If your scale helps you to make the graph, cool. I can't tell you what to do for your points, though. I'll just say, yes, you can monkey with the scale of this. Okay. We're kind of hurting on time here, so let's get motoring. Transformations. I see vertical reflection or reflect in the x-axis. I see a horizontal translation, backwards down, left 4. A vertical translation, regular down, up 6. And I completely skipped over 3. There's a vertical stretch by a factor of 3. The parent graph, who's your daddy? Just plain old absolute value of x. Remember that parent graphs are always as simple as it gets. If I'm going to graph it, then I'll take my vertex and I will move it left 4, up 6, and from there we will head down 1, 3 to 6, because you're talking about 3 times as far. The power of Christ compels you. We have, essentially, it's a slope on the right side. So down 3 over 1, 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 and mirrored across an axis of symmetry. There she be. So, what I'm going to say is, did you get it, did you get it, did you get it, did you get it? Hopefully you know what the parent graph is, so I'm just going to ignore that for now and say, do you have the correct graph? Yo.
I made my y's go by 3, so it's just
Okay, and that's exactly what I was trying to get to with Paul without actually saying it. Could I graph that same thing and just say my y's are going by 3s? Yeah. You got to be careful about where you put your vertex, though, because now it would be left 4 boxes, up 2 boxes, because that's up 6. If you did that, yeah, cool, because now it's down 3, right 1. It looks like a slope of -1, but because you went by 3s, you're still right. Okay. All right. I didn't have anyone ask questions. No one wandered down during Spartan time. No one asked on Remind to save us some time because of issues with Frank and putting something up there that we probably need to review. Y'all cool if we just move in? Just go to the next thing? Review time? Okay. Then, you know the drill. Devices over there. Don't scatter them over the entire counter. Okay? I use some of the counter space. Like, try to cluster them in an area. Okay? All your phones and watches and fun little doodads, throw them over there and act like they're kind of like a herd. Okay? They want to be together. They're...
It can't leave. I can't let it go.
Ashley, you have every right to just like smuck him upside the head as you walk by. So.
Did I do it?
How much you grin when asking that worries me for his safety. So. All right. 2, 3, 4. Yes or no?
Yeah.
Okay, then send that one back there. Okay.
Are you mentally stable? What's that one?
Holden. Might want to go wash the back of your arm off.
Oh yeah, I saw that. I didn't know. I was sitting here to look at
That's like letting someone shave something into the back of your head and just letting it happen.
Sure.
God. So we have start with continuity test. Okay, this is like super off now. We're gonna play this game again. So I'm allowed to write on it, I'm just not allowed to touch it. Okay. I need to do the continuity test. I see a rational function. What's the very first thing I should do? I see a rational function. What should I do? Factor it, right? I have to factor this because that might inform my decision. And lo and behold, there is actually something going on here. If I cross that out, what's up?
Do the both the negatives cancel out or just the negative and?
It's x minus 4 with x minus 4. Okay, factors can cancel. Once those factors cancel out, I know that there's a hole at x equals 4. It's always the zero of these factors. If there's a hole, just before I even do the continuity test, do you remember what type of discontinuity that is? Ooh, controversy. Removable discontinuity because I removed a factor. Now, the test for it is find the function of 4. If I plug 4 into the original, I end up with, you can't do that. The limit of my function as x is approaching 4. Now, remember, there's just a hole. The graph still exists, but there's a hole right here. So it's still going to approach whatever it would have been if there wasn't a hole there. So the easiest way to do this is just shove 4 into what's left and say 2 over 8 is 1/4. Alternatively, I'm going to assume that you're pressing the buttons on your calculator because I don't want to bring a calculator up here because Frank sucks. Y'all remember? Dump the original into the calculator. And then if I want to test the limit at 4, I'm going to go to 3.999999, 4.000001, and I'm going to see if those are headed to the same place. And they should both be going to about 0.25. which is 1/4. Or I can plug it into what's left. And the last part of the test is you see, does the function value equal the limit? And since it fails, it passes, it fails, well, it failed any one part of it, it is discontinuity, or is discontinuous at that point, and we said it was removable discontinuity at x is 4. You go and do the same thing again for -4. I try function of -4. When I plug -4 in there, this is where putting the function into y1 and then just going to the ask feature on the table saves you all the work on this. Okay, error, you can't divide by 0. Then try the limit. As I approach -4 from the left, so I go to -4.000001 down to -infinity, right? But as I approach it from the other side and say -3.999999, positive infinity. They are going to opposite locations, so the limit does not exist. Ironically enough, ugly equals ugly to see if the function value equals the limit. So it fails, it passes. What type of discontinuity do we get? Infinite, because it went to an asymptote and disappeared into infinite directions. So infinite discontinuity at x is 4, -4. Okay. Notes to yourself. This is all I need to see. You don't need to have the tables. You don't need to sketch the graph. Do the work on your calculator and just write the stuff. Write the test. That's it. Okay. When I look at this, what I'm probably looking for points is, did you do the test? Did you do it correctly? Do you have the right type? Did you do the test? Do you have the right values? Did you say the right type discontinuity? I'm probably going to say 6 points for this one and take 1 from the next one because it's easy. Okay? Usually it's 5 points problem, but some of the problems on here are easier than other ones, so I'll shift that around. Okay, use the graph of the function to determine the end behavior. Written as limits. I dump that in my calculator, and if I want the end behavior as we head all the way off into the wild blue yonder on both sides, how do we do that? Really big numbers, positive and negative. Spam 9s, okay? Just try not to overflow error your calculator. Some of you are talented. Okay. And I'll see my limits of my function as x approaches -infinity and the limit of my function as x approaches positive infinity. And that's how we write it. End behavior as limits. And as I head both positive and negative, this one should be headed to -2. Okay, when I spam 9s, it's going to get close. It'll be like negative. Well, if you do it far enough, the calculator will just give up and say, fine, -2. Even though it was -2.000000000000000000083. Okay. Eventually it'll just give up, yeah. Okay, so just making sure we understand what end behavior is. Please make sure you write them as limits. Yo.
Can you write both of them, or can you write as x approaches +1?
And when I did my trial run of this, that's exactly what I did. I put plus or minus infinity because they head to the same value. I'm cool with that. Yes, sir. 3. Locate the extrema. So I'm gonna come over here to Frank. Say hi, Frank. And we'll plug in our function. Y is it's like back on dial-up in 1996 plus x to the third minus 3x squared minus 5x minus 2. Okay, jeez. There we go. We got it. Maybe, possibly, could be, chance of. All right. Second, calculate. If I want to find extrema, I'm just going to assume that there's probably a minimum on here. Y'all remember the sign test or leading term test for end behavior polynomials? It's a positive, even polynomial, so I know it's going to go up to positive infinity for its end behavior. So I know somewhere in there it's got to have a minimum. So I'm just going to start with that. Well, it depends whether... Okay, so right here, we've talked about this. What is this? Point of inflection. Those aren't extrema. It is still headed down. In fact, if you were to factor out the polynomial, it is x minus 1 to the third, or x plus 1 to the third. That's why it looks like a cubic at that 0. So I only see a minimum. Like, I don't see anything else. So I'm going to put left boundary here, right boundary there, as long as it's pointing in Frank. Frank? Okay. Hey, take a look at this. Negative, or 1.24999999. What is this? Which is 5/4. Okay. So I would write that, and what would I classify it as? Right? You had to correct yourself. Usually they're relative because it's somewhere in the middle of the domain. In this case, or middle of the range. In this case, it was actually an absolute minimum. That was as low as it ever went. So what place value do we go out to though for these? Thousandths. Go out at least 3 places. Okay. No, you cross-eyed. Well, no, you tell the coordinate. Okay, average rate of change. Hey, we don't need Frank for that one. Or we don't need a calculator for that one. What I'm looking for is the function of x2 minus the function of x1 over x2 minus x1. This is the official formula. Well, that's just a fancy way to say what? Find the slope. Okay. Find the slope between these 2 points since we can't find it on a curve. So I'll plug in a 3. Get 27 minus 21 is 6. Is 6 minus 4 is 5? Wait, 6 minus 4 is 1. 2. 2 words. 27, 21, 6, 4, 2. There we go. Plug in a 1. 1 minus 7 is negative 6. Negative 6 minus 4 is negative 10. Over 3 minus 1 is 12 over 2 is 6. So would I say on this interval is the function increasing or decreasing? It's a positive number, increase, positive slope. Y'all remember? Positive slope is going up the hill, negative slope is going down the hill. Cross-country skiing has no effort, and then your remains are undefined. Right? Remember the different slopes? Okay, Mr. Slope Guy, I think. I remember a couple, Slope Dude. I remember seeing a couple years ago, work was in the copy room making like 3,000 laminated little Mr. Slope guys. So, no, that's all it was. Average rate of change is just, since I can't find the slope, I'll find the kind of slope. Okay. Identify the parent function. State the transformations applied to create g of x. What type of function? Okay. Now, technically, it could be any odd function, but we're just going to assume cubic for now, and we can test that. I'm going to say f of x was x cubed. To it, I took my point of inflection that's usually in the middle, and I moved it 2 to the left, 3 down. So, well, it does just say to state the transformations. We don't actually have to write the equation. Huh. So we're going to have a horizontal translation back to, we're going to have a vertical translation down 3. What else?
We give the y-axis
We can actually do both here, right? Because a cubic is symmetric to the origin. So that means a reflection about the y-axis or a reflection about the x-axis will result in the same graph. So you could actually say either one on this. If you say reflection in axis. I don't know, whichever one you said, right? They're both right. Okay, Paul, you said no stretch. How do you know that? Okay. A cubic or a quintic or any odd function should, from the point of inflection, move over 1 and vertically 1. Because 1 cubed, 1 to the 5th, 1 to the 7th is always 1. So I know there's not a stretch. I can, however, test to see that it was actually x cubed by going out further. If this is 1, 1, and I think it's cubed, this should be 2, what? 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's how I know it is actually x cubed and not x to the 5th. Because if it was, it would have been back 1 up 30 friggin' 2. And that's a lot. So, if I was writing the equation, I would accept both negative out front, x plus 2 cubed minus 3. I would also accept negative x plus 2. Oh, wait, how do I make sure that this still works? I could either say negative x minus 2, like this. Do I? Don't I? Do I put a plus there? Do I put a minus? What does it need to be? Okay. If I have a negative on just the x and I say plus 2, keeping it like this, I don't have b separated from x minus h. This would be incorrect because technically I would need to do this, which is now not the same thing. Do you see why we just say screw it and write it as a? Some kids get a little cross-eyed when you start messing with b because it's bass-ackwards land. So just write it in the a spot instead. Okay, just easier. And finally, can you do a piecewise graph that involves all of these transformations? I didn't include any stuff about the function operations we did yesterday, because that'll just be on the next quiz with the rest of 1/6. So, absolute value, this will move left 4, up 5, horizontal and vertical translations respectively. So 1, 2, 3, 4, up 1, 2, 3, 4, 5. What do I do from there? Okay, slope is -1 times 1, a times b. So we're going to go down this way. All right, but the problem is I only care about this from -7 to 0. So go back to 1, 2, 3, 4, 5, 6, 7. I will put an open circle because it's not or equal to. Erase everything that came before that. All the way to 0, I will put a closed circle because it says or equal to. Then square root of x plus 1. Now here's the fun part. This one starts here with an open circle, right? Not equal to. And from there, it's just regular square root, which is up 1 over 1, up 2 over 4, up 3 over 9, and you would shoop into the wild blue yonder, except this one is supposed to stop here.
Can you write the open closed circle with the pencil?
Do you just circle your
Can I what?
dot?
How do you write that with the?
Okay, so here's what's happening. Because there's an open circle where a closed circle exists. Does it exist? Yeah. So the end result is actually open circle that.
Is it okay if you just draw a thing around it? Does that make sense? Like it's okay if you draw a circle around that 0 point.
Yeah.
And
Okay.
draw it as the final function.
So if I saw you do closed circle and then open circle around it, well, I still see the closed circle there. So you're fine. This is when we were first talking about jump discontinuity, when I said, don't just assume because there's a piecewise function, it's jump discontinuity. If I were testing this particular function at x equals 0, well, the function of 0 is 1. Plug it in here, plug in a 0, -4 plus 5 is 1. The limit, this function is approaching 1, this function is also approaching 1. So even though it was a jump, or even though it was a piecewise function, it was still continuous at 0 because one rule started where the other one stopped. Okay? All right. You have a boatload of time. When you are done, okay, we kind of goofed this up last time. Do not cover my entire counter with your notebooks. Quizzes in basket. Not notes in basket, quizzes in basket. Pile next to basket of all the other stuff. Okay? That's it. Just pile O stuff. Your daily quizzes, your notes, and your assignments. If they're in a notebook or a binder or something like that, leave them in there. As long as it's organized, we're good. As long as I can tell what's what. Y'all were pretty good about this. Naturally, kids who are up in pre-calc are more organized than my friggin' freshmen in algebra half. That's it. Just put the stuff over there. When you're done, no devices until the people next to you are done. Okay? We don't want Hannah up here playing Geometry Dash while Aubrey's still trying to do her test, okay? Like, wait till the people around you are done before you start doing things that might be distracting to them. People are going to finish with a lot of time left over. Please stay quiet and just let everyone finish, okay? Be respectful of that. And there you go. You got the rest of the time.